If the air handling unit designer doesn't have service experience, then you will design an air handling unit which will be very hard to be serviced and maintained. And if you look at this air handling unit, everything that changes its color in red are the probes, the actuators, which are actually controlling the airflow and the temperature or the air humidity. We also have on the right hand side to the bottom the variable speed drivers, which get instruction from the programmable logic control. So by looking into this video, you'll observe how many things you have to observe when you design an air handling unit. You have the actuators which are controlling the valve that allows the glycol or the heating agent to pass by through a heat exchanger, so we can control the air temperature and humidity. It is not very hard if you learn your lesson, but sometime I came across an awkward situation in which the designer, when designed the AHU, disconsider a lot of things that can probably only be observed after you service this AHU for many years. If we want to control the temperature and relative humidity for a group of rooms, we have to make sure that all these rooms have the same heat load and the same air change rates, and the room have the same volume. Otherwise, that will not be possible. We have to have an individual temperature and humidity control. Otherwise, the system will not work. To achieve the set points, the air must pass by through a group of heat exchangers. The heat exchanger's capacity and performance, it is directly affected by the glycol, the steam, the water or the refrigerant which passes by. This is a picture I took from the real world. This is a Siemens HMI, and here you will see the cooling valve, the heating valve, the humidifier. But don't get me wrong, you can have more cooling or heating heat exchangers. So as you will see, this is a PID system, and the actuators will allow more or less cooling or heating agent to pass by through a heat exchanger, affecting its capacity. In this picture you will see the fans that move in the air through the heat exchangers. So the temperature of the air is directly affected by the heat exchanger temperature. Sometimes you have to be really careful. If you vary the airflow, then the temperature will vary even if the heat exchanger temperature it is constant. I think I talked about this in some other videos, but I will talk again towards the end of this video. Control strategy, it is very important. That's why the HVAC engineer will write good control philosophy, and the software engineer will understand what the HVAC engineer wants. So with a good control strategy and with a good software equipment, you can control the temperature, the relative humidity and the airflow perfectly. In the last video I described why we are using actuators and how we can control the heating or cooling agent through a heat exchanger to increase or to decrease the heat exchanger's capability. And later on you will see that it is not enough to have an actuator that allows 100% the heating or cooling agent to flow through the heat exchanger. Also, it is very important to consider the temperature of the heating agent or cooling agent, because they affect directly the heat exchanger capabilities. You will observe now that the heating agent is not passing by through the heating heat exchanger or the cooling heat exchanger. the actuators are holding the valves off, so the heat exchangers are on standby mode. If the premises are getting too hot, then obviously the actuator will allow the cooling agent to pass by to the heat exchanger. The heat exchanger will get cold, and then you'll start cooling the premises. When the cooling reaches the set point, the cooling heat exchanger will be again put on standby. If you'll observe that the cooling agent is not passing by through the cooling heat exchanger, the actuator acts onto the valve, and the valve restricts the cooling agent to pass by to the heat exchanger, and then the room will not cool anymore. But if the temperature will continue to drop into the room, then the room thermostat will instruct the BMS to enable the heating system. So the actuator which act on the valves that allow the heating agent to pass by to the heat exchanger will be enabled. So you will start in this case to heat up the premises. When the temperature reaches the set point, then the heating will be turned off. The actuator will act on the valve, and the heating agent will be restricted, and it will not pass by through the heat exchanger. And then both of these heat exchanger, the cooling and the heating, will be on a standby. Guys, I hope you know there's a bandwidth in which both of the units will be on standby mode. That is the dead band. Sometimes the temperature it is okay, but as you'll see in this case, we want to remove moisture from the air. So how can we remove moisture? We have to run the heat exchanger below the air's dew point. So in this case, the heat exchanger will be very cold, and then we will have a side effect. The air gets very cold, and the premises will get very cold. Then the room or the office thermostat will send an information to the BMS saying that the room is too cold, and then we have to reheat the air. So the BMS will enable the heat exchanger. So we will run the cooling coil very cold, and the air will drop the moisture through condensation, and then the dry air will be reheated by the heat exchanger. This is the way we control the temperature and the humidity. But let's think about what happens if the humidity is too low. Sometime when we cool the premises, we have a lot of moisture removed as a side effect. If you run the heat exchanger very cold, the heat exchanger will go below the air dew point, and the air will leave droplets, will condense the moisture onto the heat exchanger. Moisture will drop onto the drip tray and will be eliminated by the condensate pipe. Now, how can we compensate for this? On the right hand side, we have to fit a humidifier which will compensate for the humidity we lose into the cooling process. Also, you can see here the heat exchanger is not running, only the cooling heat exchanger runs, but in the same time, as a side effect, it will dehumidify the air, and we have to compensate that by using a humidifier. If you design the system carefully and you will balance the system properly, you will never have trouble. Please stay tuned, because in the next video I will talk about cooling distribution. I'll show you how to avoid the icing up phenomena if you use glycol that runs below zero, about system which using defrost, and also I will show you how they behave when you're passing by through each coil, either heating, cooling and humidifier. Thank you.